Welcome, mathletes. I've tried to record the solution for this problem several times now and messed it up in various ways, but now I've gotten more coffee and I'll roll some dice and we'll see how this goes. All right. A 48-foot extension ladder is propped against a building. The base of the ladder is 13 feet from the base of the building, and we'd like to know how far up the building the ladder reaches. To get organized, I think a diagram would be helpful. My buildings always look kind of rectangular, but you can be more artistic if you would like to. We have a ladder propped against the building, diagonally off to one side, and then it rests on the horizontal ground. In these kinds of problems, our buildings are always perfectly vertical, the ground is always perfectly horizontal, and the ladder is diagonal, and it doesn't have any sag to it or anything like that. We get a situation where we have a right angle between the vertical building and the horizontal ground. And so the building, the ground, and the ladder make a right triangle for us. And that will help us use, or that will allow us to use the Pythagorean theorem to do some solving. To label the parts that we know, we have a ladder that is 48 feet long. The base of the ladder is 13 feet from the base of the building. That's the horizontal distance along the ground. And the question, how far up the building does the ladder reach, means that they're asking us to find the vertical distance in the triangle. And that, since it is adjacent to the right angle, that is one of the legs of the triangle. Let's call it A. That's the part that we don't know. The Pythagorean theorem, a squared plus b squared equals c squared. Let's fill in the parts that we know. A squared plus 13 squared equals 48 squared. A squared plus 169 is equal to 2,304. Solving this for a squared first, we need to subtract 169 from both sides of the equation. A squared equals 2,135. To get the a isolated, we can either take the square root of both sides of the equation or take the 1/2 power of both sides of the equation. You'll only get one answer here because we're talking about lengths, and so we want the positive answer to an equation like this. I'm going to take the square root of both sides of the equation. The square root of a squared equals the square root of 2,135. When I do this calculation, a is approximately 46.21 when I round to the nearest hundredth, and that will be measured in feet. That will be the vertical distance up the building that the ladder reaches. Let's see if this makes good reasonable sense. The hypotenuse, or the ladder, is 48 feet, so 48 is too large for a vertical distance. Our vertical distance is 46.21 feet. It's less than 48, so that part is reasonable. And then the two legs together, so if you added the a and the 13, when you add those two together, they need to be greater than 48. And if you think about this or do a little bit of solving, you'll find out that your a value needs to be greater than 35, and our a value is. So that means that we've made good reasonable sense in this problem. Hooray, I made it through this one.